Hi everyone, welcome to my YouTube channel. Let's start with today's topic, which is one-dimensional potential barrier. What is a one-dimensional potential barrier? You can imagine it classically like a ball is moving in a direction and there is a wall along its path. So the ball will bounce back after collision with the wall, but in case of quantum mechanics the story is something different. Let's see how it works in quantum mechanics. So let's say a particle is coming from negative x direction and moving towards the positive x direction, and there is a potential step or potential barrier of height v0 and width a in its path. Let the mass of the particle m and the energy E, and the potential is defined as V0 for 0 to A and 0 otherwise. Let's see the case where E is less than V0. So the particle doesn't have enough energy to pass through the barrier, and in classical physics it will never passes through the barrier. For x less than 0, the Schrodinger equation becomes d2 psi 1 dx square equals to minus 2me by h cut square psi 1. I have divided this in three regions. This is region 1, this is 2 and this is 3, and I am defining the wave function in region 1 as psi 1, in region 2 as psi 2 and in region 3 as psi 3. So if we write alpha equals to root over 2me by h cut, which is real and positive, we have the solution of psi 1 as a e to the power I alpha x plus b to the power minus I alpha x. A and b are constants, and this represents a superposition of two waves. One is coming from left and traveling towards the positive x direction, and one is traveling towards the negative x direction. So A is incident amplitude and B is reflected amplitude. For the region 0 to A, that is the region 2, the Schrodinger equation becomes minus h cut square by 2m d2 psi 2 by dx square plus v0 psi 2 equals to e psi 2. And after simplifying, the equation becomes d2 psi 2 by dx square equals to 2m into v0 minus e by h cut square psi 2. And we are writing beta equals to root over 2m into v0 minus e by h cut, where beta is real and positive. So the Schrodinger equation becomes d2 psi 2 by dx square equals to beta square psi 2, and the solution is c e to the power beta x plus d e to the power minus beta x, where c and d are constants. For the region 3, that is x greater than a, the Schrodinger equation is same as for the region 1, that is d2 psi 3 by dx square equals to minus 2me by h cut square psi 3, or we know that alpha equals to root over 2me by h cut, so we can write the solution as f e to the power I alpha x plus g e to the power minus I alpha x. But in this region, that is in region 3, we cannot have a wave traveling towards the left because there is no barrier so that it can reflect from. That is why we put g equals to 0, and our total solution becomes f e to the power I alpha x for x greater than a or region 3, and c e to the power beta x plus d e to the power minus beta x for the region 2, that is x from 0 to a, and a to the power I alpha x plus b to the power minus I alpha x for the region 1, that is x less than 0. Continuity of psi at x equals to 0 gives a plus b equals to c plus d. You just have to put x equals to 0 in these two equations, second and third, and you get this. Similarly, if we derivate the psi and put x equals to 0, we get this equation 2. Now multiply equation 1 with I alpha and add it with equation 2. After adding and simplifying, we get a equals to 1 minus I beta by alpha into c by 2 plus 1 plus I beta by alpha into d by 2. Now multiply equation 1 by I alpha and subtract equation 2 from it. I have just did that and I get b equals to 1 plus I beta by alpha into c by 2 plus 1 minus I beta by alpha into d by 2, equation 4. So continuity of psi at x equals to a gives this equation 5. You just have to put x equals to a in the first two equation, the psi in region 3 and 2, and you will get this equation 5. And similarly, the continuity of d psi by dx at x equals to a gives this equation 6. Now multiply equation 5 by beta and add it with equation 6. So doing that, we get c equals to 1 plus I alpha by beta f by 2 into e to the power minus beta a e to the power I alpha a. Now multiply equation 5 with beta and subtract equation 6 from it. So after doing that, we get d equals to 1 minus I alpha by beta f by 2 e to the power I alpha a e to the power beta a. So we get the values of c and d in terms of f. Now substitute value of c and d in equation 3 and 4. What are the equations 3 and 4? The expression for a and b in terms of c and d are equations 3 and 4. So let's put the values of c and d in equation 3 first, and we get an expression for a in terms of f. So I have just put that value in equation 3 and did some simple algebraic simplifications and come up with the solution that a equals to f e to the power I alpha a cos h beta a, that is hyperbolic cos function, plus I into beta square minus alpha square by 2 alpha beta sin h beta a, that is hyperbolic sine function. You can see the steps here. You can pause the video and see the steps here if you don't understand it properly. I have done each and every step so that you can understand how I got this equation 9. Now we know that transmission coefficient is mod of f square by a square. So let's calculate that. If we first calculate f by a, which is 1 by this whole term, the coefficient of f in the right hand side of the equation, and if we square it, the exponential term cancels out and we get this. Now we know that cos h square theta minus sin h square theta equals to 1. So I have written 1 plus sin h square beta a instead of cos h square beta a, and I have taken sin h square beta a as common, and we are left with 1 plus beta square minus alpha square whole square by 4 alpha square beta square inside the bracket. Now we know that a square minus b square whole square plus 4a square b square is equals to a square plus b square whole square. So I have just used that property or algebraic identity here, and we get alpha square plus beta square in the numerator, and we have 4 alpha square beta square in the denominator. So we get if mod square by a mod square equals to 1 by 1 plus alpha square plus beta square by 2 alpha beta whole square into sin h square beta a, and we know this is the transmission coefficient. Now if we put value of c and d in equation 4, what is equation 4? This is equation 4. B equals to 1 plus I beta by alpha into C by 2 plus 1 minus I beta by alpha into D by 2. So put values of C and D in these equations and do some simplifications. Similarly I have done in case of A. So you can pause the video and see the steps. It is very clear how I got the equation for B or the expression for B in terms of F, the equation 11. Now from equation 9 and 11, what is equation 9? The expression for A in terms of F was the equation 9, and the 11 is expression of B in terms of F. Now if we divide B by A, we get this equation. So F cancels out and we are left with minus I alpha square plus beta square by 2 alpha beta into sin h beta a by cos h beta a plus I beta square minus alpha square by 2 alpha beta sin h beta a. Now if I square it, I get this equation, and similarly I will put 1 plus sin h square beta a instead of cos h square beta a, and after simplifying as before I got this equation alpha square plus beta square by 2 alpha beta whole square sin h square beta a whole divided by 1 plus alpha square plus beta square by 2 alpha beta whole square sin h square beta a. So this is the reflection coefficient. Here we can see that although E is less than V naught, the transmission probability T is not 0. This phenomenon is classically impossible. This is known as quantum tunneling. If beta A is very greater than 1, then we can approximate sin h square beta a by e to the power 2 beta a by 4, which is very greater than 1. Now we have the equation for t as t equals to 1 by 1 plus alpha square plus beta square by 2 alpha beta whole square sin h square beta a, and we are using sin h square beta a as e to the power 2 beta a by 4, since beta a is very greater than 1, and we can neglect 1 in the denominator because e to the power 2 beta is very large quantity. So the equation becomes 16 alpha square beta square by alpha square plus beta square whole square e to the power minus 2 beta a. Now we know the values of alpha square and beta square, so let's calculate alpha square plus beta square, which is 2m v naught by h cut square, and alpha square beta square equals to 2 by h car square into 2m v naught minus e by h car square. So 16 alpha square beta square by alpha square plus beta square whole square equals to 16e into v naught minus e by v naught square. So the transmission coefficient becomes 16e v naught minus e by v naught square into e to the power minus 2 beta a. And the wave function looks like this. This is sinusoidal function in the region 1 and exponentially decaying function in region 2 and again a sinusoidal function in region 3, but the amplitude is reduced very much in the region 3. So that's all for today. Thank you for watching this video. I hope you have enjoyed. If you like my video, please subscribe and share. See you in the next lecture.